Welcome back to the Topic Blast revision series. This is the day 9 walkthrough, and today's topic is converting between fractions, decimals and percentages. I hope you've had an opportunity to practice the questions yourself, and we're going to go through the answers to the booklet in this short video. In this question we're asked to write 8 over 20 as a decimal, and we're going to look at both a non-calculator method and a calculator method. So the non-calculator method is we want to get this number and change our denominator to be 10 or 100 or 1000. Now we can get it to 10 in this case, and we just divide that by 2. And then 8 divided by 2 gives us 4. And then simply we're doing 4 divided by 10, which is very straightforward, and we get 0.4. And dividing by 10, 100 or 1000 is much easier, which is why we aim to get it to over 10, over 100, over 1000. Now, if this was in a calculator paper, all you have to do in this case, if you have the correct calculator, is put it into your calculator. Now, this may seem obvious, but it often comes up with questions, and then students use a non-calculator method. Okay, so it's really important that we remember that on a calculator paper you can just put that in there and it'll convert it for you. And the next question looks very similar. It asks us to write 5 over 7 as a decimal. Again, we can do this using a calculator or a non-calculator. Obviously on a calculator, we just know to use the calculator, and the calculator will just do that work for us. But obviously that's not what we're thinking about here. We're thinking about it in a non-calculator method. Now the problem here is that 7 can't be made into 10, 100, 1000, 10,000. So there's nothing that we can do for that one. So in this case, we're going to have to use division. And we're doing 7 into 5. Now 7 is quite a weird number because it's quite a long recurring decimal place when we look at 1 7th or 2 7ths or 5 7ths in this case. So we're going to have 4 zeros, but we're probably going to need some more. So we're doing 7 into 5, and that doesn't go. And then we're looking at 7 into 50. Again, ignoring the decimal point for now. Obviously the decimal point lines up, but we're just going to ignore and just treat that as if it's 50. 7 into 50 goes 7 times, because 7 7s are 49, with a remainder of 1. Now we're doing 7 into 10, that's once, remainder 3. 7 into 30 goes 4 times, remainder 2. 7 into 20 goes twice, remainder 6, so we are going to need a few more zeros here. So 7 into 60, well 8 7s are 56, so that's 8, remainder 4. 7 into 40 goes 5 times, remainder 5. And 7 into 50 goes 7 times, remainder 1. Now what you'll start to see here is that this pattern is starting to repeat. It's gone 7, 1, 4, 2, 8, 5, and then we're back at 7 again. So as a decimal, this number is 0.71428 recurring. Now when we've got recurring decimals, we put our dot on top of our first recurring digit in our pattern and the last recurring digit in our pattern. So 5 7ths is equal to 0.714285 recurring. Okay, so just remember, if you can't convert it, getting it to 10, 100 or 1000, we're just going to divide the denominator into the numerator, and that will give us our decimal answer. Now this third question asks us to write 0.12 as a fraction in its simplest form. So really straightforward. We start with 12, because that's the numbers after it. That's all the digits we have without the 0. Then we're going to put a 1 on the very left here. And then because we've got 1, 2 decimal places, we're going to put 1, 2 zeros in our answer. So the number of decimal places equals the number of zeros. And then from there, we can very simply just simplify that, which is 6 over 50, which is then 3 over 25. The other thing we can do to remember that, if we don't remember the 2 zeros, is this is the hundredths column. So because it's in the hundredths column, it means it's over 100. So we look at the last digit and figure out what column that in, and that tells us in the hundredths column, which tells us what our denominator is. And then obviously simplifying, we're just looking at what we can divide by. So in this case, we divided by 2, and then we divided by 2 again, and there's nothing else that works. So that's it in its simplest form. Now the next question is very similar to the previous one. It's asking us to write 3.2 as an improper fraction in its simplest form. Again, in this case, we're going to write our digits, get rid of the zeros, but there's none here, so that's 32. put our 1 underneath. There was one decimal place, so there's 1 0 in our answer. So we've got 32 over 10, which makes sense because they told us it was an improper fraction. Now getting that in its simplest form, we just have to divide this by its common factor. So 2 works again in this case, so 32 divided by 2 is 16, and 10 divided by 2 is 5. And that's an improper fraction in its simplest form. Simplest form doesn't imply that it's a mixed number. It implies that there's nothing that can divide the 16 and the 5 other than 1, but if you divide it by 1 you end up with the same thing. So that's our answer to this question. Now we're looking at recurring decimals and 0.36 recurring as a fraction in its simplest form. Now you may have seen these before and you may be able to do them in your head. However, the method I'm going to show is the algebraic method, because often you get questions where it says prove algebraically that this recurring decimal equals this fraction, and you have to know this method, so it's quite a useful one to know. So the first thing we're always going to start with is we're going to say x is equal to what we have, 0.36 recurring. Now that 36 recurring, remember, means that what we have is 0.36363636 forever, and that just continues forever and ever and ever. What we're going to do is we're going to start scaling this up. And we're trying to get to a situation where we're going to have 2 recurring decimals, or 2 equations where the decimal on the right hand side of the decimal point is exactly the same. So if we do 10x here, that brings a 3 across, and remember that 363636 continues forever. So this changes then to 6,3 recurring. So the 3 and the 6 swap around because we've moved the first 3 over. So then the 6 becomes the number immediately after the decimal point, and then it's 3, and then goes 6,3, 6,3, 6,3, etc. If we do our next one, so 100x, and again we're always multiplying by 10, bring a 6 across, that becomes 36 point, and now the 3 is back at the front, 3, 6 recurring. And we can see now that this equation, we'll call this equation 2 and this equation 1, because both of these have exactly the same recurring pattern to the right of your decimal points. So they're the 2 equations we're going to do. Now what we're going to do is we're going to do equation 2 subtract equation 1. And again, the green here is useful to write, but you don't need to. Really, all you need to write in this question is what I've written in red. So we're now going to subtract equation 2 and equation 1. That gives us 99x. And then because the decimal places on the right hand side of the decimal are exactly the same, we can just ignore those. And all we're doing is looking at the left, and we're doing 36, take away 0, which is 36. And then we're just going to divide both sides by 99, and we get x equals 36 over 99. So that's it written as a fraction. Now remember, it asked it for its simplest form. So we need to find a number that divides both of those. The numbers to look at when you're dealing with 99 or 90 or 990, you're going to look for 9, you're going to look at 3. If it's 90 or 900 or something like that, you're going to look at 2s and 5s. But 3 and 9 is a good one to start with. Now both of these numbers can be divided by 9. So 36 divided by 9 is 4. And 99 divided by 9 is 11. So we've divided both of those by 9. And 11 being a prime number, 4 doesn't go into 11, so that's our answer. So we know that 0.36 recurring is equal to 4 over 11 as a fraction. Okay, another one of these, and the only difference here now is we've actually got a number here to the left, to the right of our decimal point that's not recurring. So that just makes this slightly different, but this is where you start ending up with the zeros on the end of your denominator that I mentioned in the previous question. So again, as always, we start with x equals the decimal that we're given, so 0.173, and again, only the 7 and the 3 are recurring. Now we've got 10x, that gives us 1.73 recurring. Again, our decimal isn't exactly the same yet, so we're going to go again. 100x is equal to 17 point. Now the 3 has moved up, and then it goes 37, 37, 37. Because remember, it's only the 3 and the 7 that are recurring. And then we go one more, because none of those decimals match exactly. And that gives us 173.73 recurring. And now we've got our 2 equations. So if we look at this equation here, the 10x, that can be equation 1, because that's 0.73 recurring. And then the 1000x, which again is 0.73 recurring. And again, the reason we want that is because we can then just subtract equation 2 and equation 1, and the right hand side of that decimal just disappears, they just cancel each other out. So subtracting those, 1000 take away 10 is 990x. And then ignoring the right of the decimal point, only looking at the left, 173 minus 1 is 172. Finally, dividing both sides by 990, you get 172 over 990. Now earlier I mentioned 3's and 9's, but obviously here we've got a 0 in the end, so we can also use even numbers. So we can use 2, we can use 5, and we can use 10. Both of those numbers are even, so we can divide both of those by 2. Dividing both of those numbers by 2 gives us 86 over 495. And we've got to a stage now where that is the simplified answer. So we know that 0.17373 recurring is equal to 86 over 495. And that's our final answer. So those last couple of questions have looked at converting between fractions and decimals or recurring decimals to fractions. So it was looking at that relationship. These next couple of questions are going to look at working at fractions and decimals and then how we get those to percentages and vice versa. So first one, we've got a non-calculator question here. It says to write 7 over 25 as a percentage. Now percentage or percent means out of 100. So a percent is always out of 100. So very simply, we find the equivalent fraction that's out of 100. And we go, okay, well 25, we can just times that by 4. And then we do the same to the top, 7 times 4, which is 28. So we have 28 out of 100. So percent means out of 100, so that means we've got 28%. So we want to make our denominator into 100. That may involve scaling down first and then scaling back up, but we need to get to a position where our denominator is 100, and then that's what our percentage is. Now if you're allowed to use a calculator, this is a little bit easier, but we're going to use a slightly different method. Okay, again, percent means out of 100. So all we're going to do is we're going to take the fraction that we're given, so 137 over 211, and we're just going to multiply that by 100. That's all we need to do. And you put that into your calculator, that gives you 64.928, and that continues on. It asks us to give our answer to one decimal place, so that gives us 64.9%. So again, if you're converting a fraction to a percentage on a calculator paper, multiply it by 100 and round your answer as required. Similar to what we've just seen, we're trying to convert this decimal into a percentage. So we've got 0.384, and we're actually going to use the same technique that we used in the calculator question for converting fractions. All we're going to do is multiply that by 100. So if you're trying to convert anything into a percentage, all you do is multiply it by 100. So a decimal or a fraction, multiply it by 100, I'll give you your answer. Multiplying that by 100 very simply is 38.4, and don't forget your percent sign. And that's how we do that in non-calculator. Very similar question here. You're just allowed to use a calculator in this case, but I doubt you would need one because again, we're just going to use the exact same method. We're just going to multiply it by 100, which multiplying by 100 should be something we can do without a calculator. Just gives us 12.62%. So again, anytime you're converting a decimal into a percentage, multiply it by 100 and you've got your answer. Okay, coming up to the final two questions now. This question is asking us to write this fraction as a percentage. Now this fraction is slightly different because we're in a position where we've got a decimal involved. So 3.6 over 8. The first thing we're going to do here is get rid of the decimal. So what we're going to do is we're going to multiply the entire fraction by 10 because that moves to one decimal place and we get 36 over 80. Now the problem is we can't get that straight to 100, but what we could do first is simplify it. Again, we're not using a calculator in this question, so simplifying this, we can divide the top and bottom by 4. If we divide that by 4, 36 divided by 4 is 9, and 80 divided by 4 is 20. And now we're down to one of those numbers, 20, which will get us up to 100 in one go. So all we have to do is go from 20, multiply that by 5, do the same to the top, and we've got 45 over 100. So sometimes we will need to simplify first before we can take that step to get it to 100. And now because we've got 45 over 100 and percent means out of 100, that's just 45%. So just remember, we always want to try and simplify that denominator down to be one of those numbers that goes to 100. Now when I talk about one of those numbers, all we're talking about is one of the factors of 100. So 1 times 100, 2 times 50, 4 times 25, 5 times 20, or 10 times 10. All of those numbers will make you 100. So if the bottom number is 50, you just double it. If the bottom number is 25, you times it by 4. Bottom number is 20, times it by 5. Or the bottom number is 10, just times it by 10. So you're always trying to get it to one of those factors of 100. But in particular, I recommend that you try and get it to one of these factors on the right-hand side. Okay, 10, 20, 25, 50, or 100. And then the corresponding number on the left-hand side is just what you multiply by. So it's quite useful to know the factors of 100. And our final question, just to reinforce it one more time, we want to convert this fraction into a percentage, and we want that using the calculator. So again, to convert a fraction to a percentage, it doesn't matter if there's decimals involved. You just multiply it by 100 and let your calculator do the work. If you put that into your calculator, you end up with 127.89, etc. So therefore, to one decimal place, that's 127.9%. Now, one thing that often confuses students is, well, this is more than 100. How is that possible? Okay, the reason it's more than 100, well, if you look here, the fraction is improper or top heavy. So with an improper fraction, because the numerator is bigger than the denominator, you're going to end up with a percentage over 100, and that's perfectly acceptable. That brings us to the end of today's video. Thanks again for watching. I hope you found it useful, and we'll see you in the next video.